further explain our calculations in simple electric circuits, simple DC circuits. We have done some videos in the past where we told you how these equations were derived. For the series circuit, I told you that the voltage is usually different. So here we have different voltages in the resistors. This is the first voltage, this is the second voltage used in the series circuit, and we call it the voltage divider. And for the currents in the parallel circuit, the currents in the two resistors or multiple resistors will be different. So you can use a current divider. So this is a voltage divider, this is a current divider. Take note of the way the resistors vary. If you are looking for a V1, use R1. If you are looking for V2, use R2. But when it comes to current divider, if you are looking for I1, use R2. And if you are looking for I2, use R1. So we're going to use that to try to analyze this circuit, the concept of voltage and current divider. But you must not forget a particular key in solving most questions involving simple circuits. Most questions involving simple circuits, the best way to analyze them is to first get the total current in the circuit. Don't forget the total current in the circuit. That is where the solution usually lies. So if you are given a simple circuit like this, the first thing you need to tackle is what is the total current coming out of this power supply. What is the total current coming out of the power supply? To get the total current, don't forget from Ohm's law, to get the total current, what we need is the total resistance. Remember, I total is V total over R total. So to get the total current, I actually need the total resistance. So can I get the total resistance, R total? Yes, I can. This is in series combination with these two in parallel. So I have series of 1 with 2 and 4 in parallel. That's what 2 times 4 over 2 plus 4. What does that give you? That gives you 2.33 ohms. That's the total resistance there. So the next thing I can go on to find my total current. My total current I total will be V total over R total. Okay, my V total is 20. This is the total voltage supply divided by R total, which is 2.33. So I have what? I have 8.6 amps. That's the total current in the circuit. Now you notice that this current will go all the way around, get to this node, and do what? And divide into two, I2 and I4. Okay, in the question, I'm to find I2. I'm to find I2 and V2. So I'm to find the current going through the 2 ohm supply and the voltage across the 2 ohm supply. So I found the total current. The total current will get to this node. This is the total current. I total will get to this node. Then it will now what? Divide into 2. So how do I divide the total current? I'll use the current divider. Current divider. Remember, to get the total, the current flowing through the 2 ohm resistor, I2, I'll use what? I total, R4. Remember, if I'm looking for I2, I use R1. If I'm looking for I1, I use R2. So I'll use it for 2 divided by R2 plus R4. So what do I have there? Total resistance is 8.6. That's total current. R4 times 4 divided by what? Divided by 2 plus 4. So that means the currents that will be passing through the 2 ohms resistor, yes, because that's 8.6. So the current will be 5.73 amps. That's the total current that will be passing through the 2 ohm resistor here. This is the current here, the 2 ohm resistor. So I found the current. So the next thing is to find the voltage. The voltage, remember from Ohm's law. Ohm's law, what will be the voltage? I2, R2. So I have V2 to be equal to, what's I2? 5.73 times 2. What do we have there? What do we have there? We have 11.46 volts. So a brief understanding of the current and voltage divider will go a long way to help you in understanding circuits like this. Remember, the first point of call is that you get the total current. In getting the total current, I needed the total resistance. I got the total resistance, I got the total current, and the next thing is I divided the total current into 2. That's by using this, and I got the current in the 2 ohm resistor as what? 5.73 amps. So after getting the current in the 2 ohm resistor, the next thing is what? To calculate the voltage, which I use Ohm's law to calculate that voltage, and I have it as this. We can follow on to solve the next question. Next question. Okay, now we have tried to use the current and the voltage divider to analyze the circuit, and I believe that is quite straight. Here we have another circuit. We have a 2 ohms and 4 ohms in series connected in parallel to a 1 ohm resistor. And we're still told to find I2 and V2. You see that this circuit here is different from the circuit which we have here. But it's still the same approach. We can either use the current or the voltage divider. But in any of the cases, we need to find the total current. Don't forget, I told you total current is very, very important. So what's the total current going in through here. What's the total current? So can I calculate total current? I total is V total over R total, but I don't know my R total. So in getting my I total, I need the R total. So my R total, of course, I have this and this in series. So that's what? That's 2 plus 4 in series times 1. That's the parallel with this over 2 plus 4 plus 1. So at the end of the day, what I have here for the total resistance is 0.86 ohms. So with total resistance, I can go on to find the total current. I total. I total is V total. The V total here is 10 volts. That's 10 over 0.866. So what's the I total there? The I total there is 11.67 amperes. So that means I have a total current of 11.67 getting towards this node. Just like I had a total current of 8.6 getting towards this node. So what happens here? The current will divide into the current I have here I2 series with 4 and the current which I have here I1. I can do a total current division there. Or rather, I can go on and use voltage division. Remember, this voltage I have here is the same across this and across this. Why? Because voltage across parallel connections are always the same. So the voltage across V1 is the same thing as 10 volts, while the voltage across 2 and 4 is the same thing as 10 volts. Look at V total is the same thing as V1 and the same thing as V2 series with 4. That's what I'm trying to say. Why is it like that? Because they are all in parallel. So I can decide to find this V24, that's the V across the 2 and 4. Look at the V across the 2 and 4 is 10 volts. I can share the 10 volts between the 2 ohms and 4 ohms resistor. So I'll do a voltage division between them. Voltage division between 2 and 4. Between 2 and 4. Okay? That's to find V2 now. V2 is V total R2 over R2 plus R4. It's not like the current division. In the current division, when you're looking for I2, here you use what? R4. But in the voltage division, when you're looking for V2, you still use R2. So that means my V2, in this case, will be V total is 10 times what? 2 divided by 2 plus 4, and you get the V2 as 3.3 volts. 3.3 volts. Remember, V2 is one of the things we're looking for. Okay? So we can go on to find I2. My I2 will be what? V2 over R2 from Ohm's law. That's 3.3 over 2, and that's 1.67 volts. Now, this is just a way of doing it. Looking for voltage division. You can still go on to do your current division. Do what we got here, where we had the current at this node. You can divide the current between the two of them, and the current you still have going through here will still be 1.67. You can do a check. Use a check with current division. Do a check with current division so that your I2 series with 4 will be what? I total R4 over R2 plus R4. R2 plus R4. What would that be? What's the I total? I total is there, 11.67 times what? R4, which is 4, divided by what? Divided by 2 plus 4. Okay? Divided by, that's R1, divided by R2 and R4. This is R2 parallel series to 4 plus R1. Since we're having a division between R2 and R4 and R1. So here we have 11.67 times what? 1 divided by 4 plus 1. So at the end of the day, what do we have? R2 and R4, 6 plus 1. I2 series with 4 will now give me 11.67 divided by 7, and here you have 1.67 amps. That's the value of the current passing through I2 and I4. What I'm just trying to use this to show you is that the current and the voltage in any circuit can be analyzed either using the current division, okay, by dividing the current. You know, here we've got the total current 11.67. Then we divided current between I2 and I4 and I1. I2 and I4 and I1. So I2 and I4 will give me I total R1 over I2 R4 plus R1. That's this. And I got the same thing as using the voltage division. Remember, you can always pause this video and rewatch it as much as you like. And if you have any problem, don't forget to get back to us. Thank you.